Okay, this is about solving equations by graphing. And there's really a simple thing I can tell you that will work for all problems. It just involves a little bit of technical ability on the calculator. But if you graph both sides of an equation and see where they cross, well, that's the answer. That'll even work for the simplest equations like this. X plus 2 equals 6. I think we're all aware that the answer is what? X equals 4, okay? But I want to prove to you that you can solve even a simple equation like this by graphing both sides of it and seeing where they cross. You're going to set y1 equal to this and y2 equal to that. Go ahead, grab your calculator. And I'm going to set y1 equal to x plus 2. Pause for a second. Okay, I've got them entered on my calculator, x plus 2 and 6. And then I just hit graph, and I see where those two lines cross. Do you see them crossing on your calculator? All right, now let's do something that's really important. We're going to do a bunch of times today. Second button, then calculate, which is right above trace, right there. Second calculate. Now, if I want to find where two lines cross, that's second calculate the intersect. And then if you've only graphed two lines, the first two questions it asks you are what are the first curve and the second curve. They happen to be straight lines in my case. I wish they didn't say curves. I wish I said lines. But anyway, first line, enter. Second line, enter. And if there's only one spot where they cross, you don't even need to like arrow over to where that spot is. That's what they intend on this guess thing. You don't even have to do that because it would just jump there automatically for you if you hit enter the third time. And it's 4, 6. How do I know that the 6 is the answer and not the 4? Sorry, the 4 is the answer and not the 6? Because look in the problem. Which one was I given, the 4 or the 6? I was given the 6. The other way to think of it is, what am I solving for, x or y? I'm solving for x, and that's why I want the x of this. X equals 4 is the answer. I'll give you another one that just, you probably would have no clue what the answer to this would be unless you use this technique. Sine of x is equal to, let's say, let me make something that would have a nice slope. 2x plus, actually we'll just say 2x. Sine of x is equal to 2x. I don't even know what the answer to that is. But I know that I'm going to graph both sides and see where they cross, and then I'll be able to get the answer that way. All right, so let's go into the calculator here. Sine of x is equal to 2x. So I'm going to this. Sine of x. So I go sine of x. And I really should have cleared before I started, but there we go. And the other part of it was 2x. 2x. Let me tell you that this technique that I'm showing you right here shows up on a typical ACT test. At least 5 questions of the ACT can be answered by graphing both sides of an equation and seeing where they cross. At least 5 of your ACT questions. You may not even notice it, think about it, but it's true because they have these big equations to solve, and if you just graph both sides, see where they cross, you got it. All right, now, if I hit graph, see the sine graph going through there? And I see the other one heading through there. All right. And now how do I tell where they cross? Second, calculate the intersect, which is number 5. And I hit enter, enter, enter. And there we go. 0, 0. So what's the answer? 0. X equals 0 is where that works. Okay. And my point is trying to show you something that you would never have gotten without like this method. Because there's some of these we could have solved without, graphing both sides. But all right, there are some other functions that you're going to have to be able to handle. Some of them are like this: x squared plus 2x equals -1, for example. Can you graph both sides and see where they cross? Yeah, works for everything. I'm telling you. What if you graph them and they never cross? What does that mean? No solution. Are there equations or problems that have no solution? Yeah, at least no real solution. You can have imaginary solutions, which opens up all kinds of crazy possibilities. But all right, so if I were to graph this and see where it crossed, that's one way to do it. But let me show you that this one actually has another way to do it. I can add 1 to both sides, and watch what happens here. X squared plus 2x plus 1 equals 0. Does that look familiar? Does that look like a quadratic? Does that look like the problems that we factored earlier, like a week ago? Right? You would have been able to factor that, right? When you factor it, you get x and plus 1 and plus 1. So what's the answer? -1. Okay. Did I solve it? Yeah, -1's the answer. If I graphed it, take a wild guess where they cross. At -1. Okay. So I can solve it by hand or I can solve it by graphing. One more thing. I could graph this thing a different way. If I graph this, it's going to be a parabola. Let's do that. Let's graph x squared plus 2x plus 1. Grab your calculator. X squared plus 2x plus 1. Clearing out these last couple that I did. X squared plus 2x plus 1. Now, could I graph y equals 0, which by the way is the x-axis, and then see where they cross? Yeah. But the problem with that is when you hit graph, you can't see the line y equals 0 because it's right on the axis. But do you remember when there's a parabola, what the important spot is? It's where it, not the origin, it's where it hits the what? The x-axis, right there. That's the important part. And where does it hit the x-axis? At -1. Do you get that? So you can graph these and see where they touch the x-axis, and there's a special function for that you have to know. Okay? Can't you just graph them all and see where they cross? Yes, but this way is used a lot because this is a quadratic, and quadratics are one of the biggest topics that you ever study in math. So a lot of parabolas out there. So we need to do this special way. It's called second calculate the zeros. Everybody go to second calculate the 0. It's number 2. And now it says left bound. You have to go and make a boundary on the left side of where the 0 point is. If you don't know where the 0 point is, this doesn't work. But I know the 0 point is about there. So I'm going to go to the left of it. And then I hit enter. And then I go to the right of it. And by the way, do you see that x equals 1 would be to the right of it? I can just hit a 1 on my calculator right now, for those of you that like shortcuts. Or I could just keep arrowing over far enough, and then I hit enter. But if let me just show you, if I hit a 1, it says x equals 1 is the right boundary. I hit enter. See how it grabbed that spot? Now, it pulled up 2 little arrows, and what it's saying is between here, and you're supposed to guess where it is. Okay, so what that means is get really close to where it is. And I think it's about there, so I hit enter. Now, you have to learn to interpret this. When it says negative 0.9999999, doesn't that pretty much mean -1? It will often be off a little bit. Hard to imagine a calculator being off. But what it's doing is trying to read its own graph. And it's not doing it algebraically. It's trying to read its own little pixels. And so it will be off a smidge. So you have to be able to be smarter than your calculator and say, well, I think it means -1. Yeah, I mean 99999, come on. That's got to be -1. -1, comma 0. And which one do we care about? The x, because it's the x-intercept. So x equals -1 is my answer. All right, I just showed you 3 ways to solve that. I showed you how to factor and solve it. I showed you how to do it with second calculate the zeros. And you can always just graph both sides and see where they cross. Let me show you that last one again. If I'm going to graph this one and graph both sides and see where they cross, I could have graphed this one, original one, and graphed this side and graphed that side and see where they cross. Or I could put it in this form, graph this side and graph that side. How do you graph y equals 0? You just type in y equals 0, and it's a line going across at the x-axis. It'll be right like there. All right, so now you got some choices. One more thing. You're going to be asked to graph some absolute values, like, for instance, this. 2x minus 5, absolute value, and then it's equal to 7. So what you do is graph both sides and see where they cross. Let's do that. But where in the heck is the absolute value? No, you don't have to even know. There's only one button you need to know to be able to find any function on your calculator. And the button is called catalog. Look for it right above the 0. See the word catalog there? You can find anything in the world that your calculator can do under catalog. So if I want to do absolute value of 2x minus 5, then, hold on, my calculator changed sizes on me there. Okay, absolute value of, I'm going to go to, here we go, right above the 0, catalog. And the first thing that pops up is ABS. Now, it happens to be alphabetical. That's why it's the first thing that popped up. If you wanted to find, like, I don't know, name another weird thing it can do. Okay, cosine, it'd be under C. So you'd arrow down a whole bunch of times and you'd get to C, or cosine. If you wanted to, oh, there's all kinds of interesting things on here. A lot of them I have no idea what they are. ANOVA, no clue what that's going to do. This calculator can do so much amazing stuff. Some of these are drawing functions, but I mean, ASM program, great. No clue. Some of these are programming commands, too. You can program the calculator to do stuff when you're in program mode, which is that PGRM button. All right, anyway, I'm going to go back to the catalog, original catalog button, because it starts me off at ABS, and that's what I wanted. ABS, absolute value of, except I wanted to be under the y equals, sorry, hold on, back to the y equals here. Clearing this off, and I'm going to put in absolute value of. So, back to catalog again, absolute value, enter. It brings up the absolute value bars, unless you have a really old calculator, in which case it'll say ABS parentheses. It's still going to do the same thing. It'll be fine. Okay, and it's absolute value of, what did we say again? 2x minus 5. So we type in 2x minus 5 and hit enter. And now the other equation is the other side of the equation, and that's 7. Enter. And I see where they cross. Graph. And do they cross? All right, this is the important part. Second, calculate intersect. See if you can get both of them to come up. If you don't know how, it has to do with the guess. When the calculator says guess, you arrow over to about where it is. I know you can get one of them to come up. I can get a monkey to do that. Second, calculate, intersect, enter, enter, enter. One of them will pop up. But can you get the other one to come up? Second, calculate, the intersect. If I just go enter, 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 it'll jump to one of them. But how do you get it to the other one? All right, I want you and the people that are of the groups that I have set up by saying you look to the middle, you know, the 2 rows. If you are on the right, I want you, the people on the right, to show them step by step how you get it to the other intercept. There's 2 places they intersect. People on the right, you are showing the person on the left with your calculator. If you don't know, they better help you, I guess. Go. Okay. Now, if you are not able to, I'm going to show you one last time how this works. You go, second, calculate the intersection, which is number 5. And then the first 2 times are enter and enter. And then when it says guess, you arrow to right where they cross. When it says guess, that's what you're doing, is getting really close. Do you have to get all the way there? Nope. You just have to get pretty close. And then you hit enter, and it'll jump right to it, and it says 6, 7. Any questions on that? All right, that's how you see where 2 lines cross. Second, calculate intersect. Okay, now, one last thought. If some of the problems at the beginning are so easy, I just don't want you to get confused because they're so easy. They give you a picture like this, and they say, what are the x and y intercepts? Well, let's say this right here is at 3, 0. Let's say this is at 2, 0. Let's say this is at 4, 0. Well, that and that are the x-intercepts. Those are also known as 3 other things. X-intercepts are the what? Zeros and the roots and the solutions. So why, if you got 4 names, you obviously know these things are kind of important. We're going to use them a lot. The x-intercepts, the roots, the zeros. Okay, how about that spot right there? What's that called? The y-intercept. That's it. You just have to name them. Okay, so your worksheet, if you pull it up right now, is called P5. P5, worksheet 1. I'd like it on your screen, and I'd like you to work on that. Let me see. We have done versions 1 and 2 of the top 20, correct? But we graded the top 20 version 2 yet. Okay, I think that was due today, but I'm going to push it to Monday. So anybody that hasn't got it done, just make sure it's done by Monday. I'll grade it in class on Monday. Okay. All right, that's all I have for finding solutions by graphing. You just graph both sides and see where they cross. Then 9 times out of 10, that works just great. And remember, if you've got something that's, oh wait, everybody stop. Put your iPads down flat, upside down so that you can't see them. Quickly, quickly. Should take like 15 seconds, but I need everybody's attention because this is an important point. All right. If the equation has an x to the third in it, it's supposed to have how many answers? If x to the third is the biggest thing it has, 3 answers. Just a second now. That, for instance, that equation should have 3 answers because its biggest power is 3. Okay? What if it only has 1 answer that's real? Then the other 2 must be imaginary. So if this graph goes like this, which you have one like this, and it only touches once, is there only 1 answer? Yes, there's only 1 real answer. The other 2 are imaginaries. You can't find them with a graph. All right? What happens if your graph doesn't touch? Like I graph it and it goes like this. No solution. What if I graph it and it goes like that? Still didn't touch. So, no solution. Okay? All right, and last thought. That one's biggest power is 4, so there should be 4 roots. That could look like that. No, actually it couldn't. Sorry. It could look like, they're both positive, so it'd have to be going up. Hold on. Say that was like that. It's got 2 places it touches, or 2 x-intercepts. So it's got 2 real solutions, and therefore what? 2 imaginary solutions. Okay, good enough. Thank you for your full attention on that. Again, your assignment is P5. In my continuing commitment to make your assignments doable, like not too long, I am allowing you to skip a few. And that's all I have for the video. If you're one of my students, you'll have to email me to find which ones you could skip.